Yeah, I'm Benedikt. I manage the Chrome DevTools team. We're in Munich, and we have 3 of us here. So Justin already gave a talk, and some of you already came to us and approached us with interesting topics. So I'm excited to learn. This is a great opportunity for us to learn what people are struggling with. Chrome DevTools as a product has many users, but we cannot easily go to each and every one of them. So this is always a great opportunity. Today I want to talk a bit about debugging, and specifically debugging with Sourcemaps. So raise your hands, who's debugging code regularly? Okay, so that's mostly everyone, except that I couldn't see the rows in behind. So who's debugging using Sourcemaps? Okay, that's not a lot of people. So, okay, so who develops with React, Vue, Angular, Svelte, or something like? Okay, that's again almost everyone. So, fun fact. If you are debugging, let's say Angular, so I picked an Angular example here, then you are most likely using Sourcemaps because you likely see this in DevTools when you're debugging your source code. You probably also likely see your project tree in DevTools. And ideally, you also see a call stack that makes sense, specifically after what Simona presented in the morning. And yeah, you do this using Sourcemaps because when you disable the JavaScript Sourcemaps, which you can easily do, you would be debugging this, which you probably don't. Okay, maybe some of you are actually debugging this. I hope not. Okay, so if you look at this view, then this doesn't make a whole lot of sense and doesn't really correspond to what you wrote. So this is not the best debugging experience. This is actually the worst debugging experience. This is like looking at assembly code when you're writing a native application, and it doesn't make you very productive in debugging. So the truth is probably 95% or more of you are using Sourcemaps. You're just not using this consciously, but that's fine. It's just debug info. So Sourcemaps are today an essential part of the web development story, but they need a bit more love, which is why we're trying to spread the word and make people aware of this, so we can move the ecosystem to a better world. Why do we have Sourcemaps? So if we look back at the web is a bit different than other platforms. So in other platforms, you always had some kind of debug info. So even the early Unix days, you had some kind of debug info because otherwise you would actually debug the machine code. And with debug info, you could at least debug your C code, which was not much better than machine code, but a little bit better than machine code. But the web didn't have this in the beginning because you were essentially writing the machine code because the machine was JavaScript. But over time, this got a little bit more complex. So specifically, Google started moving huge applications to the web all of a sudden. And Google invented this Closure compiler and also GSS for Google style sheets. And it needed a way to still debug in terms of the code that you wrote and not in terms of the code that fell out of the Closure tools. And that's basically where Sourcemaps came in. And initially, this is a long and fun story. Initially, this was just an extension to Firebug back in the days. So Firebug was a very popular extension to Firefox when there was no proper DevTools at the time. And the Closure team maintained an extension to Firebug that was using Sourcemaps, and that became so popular that it eventually turned into the Sourcemaps spec. And nowadays, it's not even just Closure tools anymore. You have this gigantic mess of tools that somehow produce JavaScript, CSS, and HTML. And you certainly don't want to look at the output of that when you're debugging, but you want to debug in terms of what you wrote. And so Sourcemaps are the only thing that actually connects what you wrote to what you're seeing in the browser. So since AI is very popular today, I thought, okay, let's ask the AI what Sourcemaps are. And indeed, in this case, it's not even making up things that are completely wrong. So this is actually almost factual. A lot of words, but in essence, it boils down to a very simple fact. A source map provides pointwise mappings between two files, essentially, or between 1 and n files. So you have one deployed file in the browser, and you have n source files that were bundled together into this. And it's a pointwise mapping. This is the important bit. So we can also look at source maps. It's just JSON data. So I was using Cursor as an example, but you can use any tool like TSC will also produce source maps, or yeah, any tool that can produce source maps. So when you look at what Cursor does, Cursor is a minifier. It's the successor of Uglify.js, and it generates a minified version of your code, and it also adds this little source mapping URL at the end, and spits out a separate file, a map file that is just some JSON, which contains a version, sources, and mappings, and some optional fields in addition to that. And the interesting bit here is first the sources. The sources is a list of all the files that were fed into the system and ended up in this one bundled file. So in this case, we only compiled hello.js. And the second bit is this mapping list, which has a very funny encoding. So this changed over time. Initially, the first version of Sourcemaps was using a pointwise mapping that would map each character in the generated code to a character in the authored code. But you could imagine that this was leading to gigantic files. And the second version already optimized this, and the third version came up with this really clever encoding, which was done by the Clojure team. And they had the problem that the source maps that fell out of the Clojure compiler initially were too big for Google Calendar, so to even load it into the browser anymore. So they had to shrink the size significantly. And the way that they did it was inventing a base64 encoding of strings to just describe arrays. And they're using this, what is called a VLQs. And it's terribly optimized for size, but there are libraries, for example, the Sourcemap codec, which you can just use. You feed in the string, and it gives you the original array. So what you see here is it's actually tuples of 1, 4, or 5 elements, and a list of those. So let's look a bit deeper into one of these tuples. So the first element is basically the column offset in the generated file. So in this case, it says column 0 in hello.min.js points to the first item in the sources array. So in hello, sources array only contains 1, so it points to hello.js. And then it has a line and a column info in the authored file. So this allows us to map back from column 0 of the generated code to line 0, column 0 in the authored code. And that's basically all the magic in source maps. And what's important here, it is a pointwise mapping. But the problem is, if you already see, this is not describing every character in the generated code anymore. So what debuggers do, since we need to translate breakpoint positions, we need to translate call stack positions, we need to map all kinds of things together. So we extend these pointwise mappings to ranges. So when we take the range from one mapping until the next one starts, and treat this as one mapping between the files. So in this case, the first starts at 0 and the second starts at 6. So we take everything from 0 to 5 and consider this as one range that maps back to the const. And you see in this case it also mostly makes sense, except that, for example, the L parameter, which is the minified version of name, points to more than just the L, so it also includes things afterwards. So we don't really map names to names. Also the hello not only contains the name hello, but also the equal sign afterwards. So when we map things to translate names, for example in the scope, we need to remove some garbage from it to make sense of it. And this is actually just a trivial example. Now, the way that this is done is not spec'd at all. So what is spec'd is the syntax of the how the source map file is encoded, but the way that debuggers interpret it is not spec'd. And every browser interprets it slightly differently, which leads to very funny situations, and which also leads to a very unfortunate situation. So, sorry. So the problems that we are facing is that the current source maps are under-spec'd, and browsers interpret it differently, generators don't generate it consistently, they don't know how the browser interprets it because the spec doesn't say it at all. It doesn't say how to resolve the sources, for example, so it only says, oh yeah, if there's a sources root, you concatenate that and then load the file. But if what falls out of it is not a valid URL, the browser doesn't know how to load the file. And then the browser makes up a story how to do this, and we do it differently from Firefox. Safari does it yet differently, and that leads to very confusing results. And as I already showed you, the mapping is pointwise, but it doesn't give you every point anymore. So, which also leads to very funny things. For example, the SAS compiler tries to emit too much information because it doesn't know exactly what the browser needs. Whereas most of the JavaScript tools emit not enough information, which leads us to ranges that are too long. And so you set the breakpoint in one position in your authored code, but we translated it to the wrong position because of the source map in the generated code. So you don't stop where you think you are stopped. But because of the mapping, what we present you in DevTools is, yeah, we stopped on the line that you wanted us to stop. But in reality, you stopped after that line because of the source map. And that leads to a very confusing debug experience. Also, again, because it's not spec'd. And source maps are very limited. So compared to debug info that you have in the native world, like Dwarf or PDB on Linux or Windows, source maps can only give you this line mapping. So this is actually only a tiny fraction of what normal debug info contains. So we have no idea about scopes. We don't know where variables are, what the lifetime of a variable is. We don't even know what the scope of a function is. We cannot make sense of the input language unless we parse it ourselves. There's no information about inlining, so if you inline multiple things into one function, then it only shows up as one item in the call stack, where in reality, this was a compiler optimization and you had 10 call stacks that were just inlined. And there's no type information, which arguably it's a bit of a question whether you want this in JavaScript, but one of the common requests that we get is people would like to see enum values from TypeScript. And this information is just lost because if you use const enums, then TSC inlines the constants. And DevTools has no idea, it's just the string value or the number value. So we don't know that this was actually this enum value. And this is normally solved by just putting type information into the debug info. So what we are trying to do is we try to we want to again standardize it. And this sounds like, so for you it probably sounds like, just go ahead and do it. But the problem is we are only at the very end of this pipeline, so we only consume the information. The actual hard work is not in the browser. We can easily adopt the DevTools to whatever the source map spec has. But we need to change the whole ecosystem, so every single bit in the ecosystem has to change, or has to be adopted to respect the spec. So every change that we make, we need to make this in hundreds of tools. And we cannot do this. We can only do this at scale when everyone works together. Also, as part of that, we are trying to make tiny changes. For example, this Google acknowledged that Jesslyn and Simona already mentioned earlier today. We're trying to get that adopted, which is actually a non-breaking change. It's an addition to the source map spec, but just threading that through all the different bits of the ecosystem is extremely involved. And you can help. So I just basically got Daniel excited. Daniel, he was now putting this into Next as I'm speaking, which is really cool. We're also working together with Vite, for example, but Vite is only one part of the ecosystem. So there's Webpack, there's TurboPack, there's, I don't know, name the 100,000 tools that do the same thing. And all of them need to be changed. So what you can do is either you help us create pull requests, or you just at least file issues like, hey, can we have this supported, please? Because when you raise awareness, and when you go, when there's multiple developers saying, hey, we want this, can we have this, please work on this, then it creates a forcing function. And this can actually move the ecosystem, or at least the parts of the ecosystem that want to collaborate. And now we can have beer.